In the high-stakes theater of global geopolitics, we often hear about the economic ripples of conflict, rising gas prices, shattered trade routes, and fluctuating stock markets. But there is a silent, far more permanent consequence lurking in the shadows of modern warfare that rarely makes the evening news. If the massive oil infrastructure of Iran were to be targeted in a major conflict, we wouldn't just be looking at a financial crisis. We would be witnessing the potential biological erasure of some of the most unique and fragile ecosystems on Earth. From the ancient mangrove forests of the Persian Gulf to the highly specialized coral reefs that hold the secret to surviving a warming planet, the collateral damage would be a toxic legacy lasting for centuries. This isn't just about energy, it's about a chemical chain reaction that could poison the very life support systems of an entire region. This is the story of why the industrial heart of the Middle East is an environmental powder keg, and why one wrong move could trigger a multi-generational ecological catastrophe. To understand the insanity of the risk, you first have to look at the sheer scale of the infrastructure we are talking about. Iran is home to some of the largest oil refineries, offshore platforms, and terminal hubs in the world. Places like Karg Island act as the narrow funnels for millions of barrels of crude oil every single day. Now imagine a scenario where these high-pressure systems are suddenly compromised. We aren't just talking about a leaky pipe. We are talking about millions of gallons of unrefined, heavy crude oil being released into a closed, shallow sea. The Persian Gulf is not the open ocean. It is essentially a giant, sun-scorched bathtub with only one tiny drain, the Strait of Hormuz. Because the water in the Gulf takes years to fully circulate and refresh, any massive toxic release doesn't just wash away. It stays. It circulates in a slow, poisonous loop, marinating every reef and beach in a thick, black shroud. The first victim in this scenario would be the corals. The Persian Gulf is home to extremophile corals, species that have evolved over thousands of years to survive in water that is much hotter and saltier than anywhere else on Earth. While the Great Barrier Reef struggles with even minor temperature spikes, the corals off the Iranian coast are the tough survivors of the marine world. Scientists consider them a genetic goldmine. They are looking at these specific corals to find the genes that might help save all the world's oceans as global temperatures rise. If a massive oil slick from bombed infrastructure settles over these reefs, it doesn't just block the sunlight they need to survive. The chemical components of the oil, polycyclic aromatic hydrocarbons, act as a persistent toxin that disrupts the very DNA of these organisms. We would be destroying the world's best hope for coral restoration before we've even finished mapping their genetic secrets. But the poison doesn't stop at the water's edge. Along the coast of Iran lies the Hara Forest, a massive expanse of mangroves that serves as the lungs of the Gulf. Mangroves are incredible biological filters. Their complex root systems trap sediment, protect the land from erosion, and provide a nursery for nearly every fish and shrimp species in the region. However, those same intricate roots are a trap for oil. Once crude oil enters a mangrove forest, it coats the pneumatophores, the specialized roots that allow the trees to breathe in the salty, oxygen-poor mud. When these roots are smothered in oil, the trees essentially suffocate. And because the mud in these forests is so thick and sheltered, the oil can remain trapped there for 50 years or more, slowly leaching toxins back into the water every time the tide comes in. It would be a permanent environmental scar on an ecosystem that protects millions of people from storm surges. Then there is the issue of black rain. When oil infrastructure, especially refineries and large storage tanks, is hit, it often results in massive, uncontrolled fires. These aren't like a campfire. These are towering infernos of soot, sulfur dioxide, and heavy metals. During past conflicts in the region, we saw plumes of smoke so thick they blotted out the sun for months, dropping the local temperature by 10 degrees. When it finally rains, that soot and those chemicals are washed out of the sky and onto the land. This black rain can poison agricultural soil, contaminate freshwater reservoirs, and coat the leaves of plants, preventing photosynthesis. For a region already struggling with water scarcity and food security, this kind of airborne chemical assault could render vast areas of land unusable for farming for a generation. The Persian Gulf is also a critical stopover for millions of migratory birds traveling between the Arctic and Africa. These birds rely on the intertidal mudflats of the Iranian coast for food and rest. If these mudflats are coated in a layer of toxic sludge, the impact ripples across the entire globe. A bird that cannot feed in the Gulf might not have the energy to complete its journey to the Siberian tundra. We would see a decline in bird populations thousands of miles away as a direct result of a localized conflict. It is a perfect example of how the environment knows no borders. A tactical decision made in a command center can result in a silent spring half a world away. One of the most inexplicable risks involves the desalination plants. The entire Middle East, including the nations across the water from Iran, depends almost entirely on desalination for drinking water. These multi-billion-dollar plants suck in massive amounts of seawater and turn it into fresh water. If a massive oil release blankets the Gulf, these plants have to shut down. You cannot run oily water through a desalination membrane without destroying the entire facility. This would trigger an immediate humanitarian crisis for millions of people. The desperation to find water would then lead to the overpumping of underground aquifers, leading to land subsidence and the permanent salt contamination of the remaining original freshwater sources. It is a domino effect of environmental failure. Let's talk about the seafloor shadow. Crude oil is complex. Some parts of it evaporate, but the heavier components eventually sink. This heavy oil settles on the seafloor, where it smothers the seagrass meadows. Seagrass is the unsung hero of the ocean. It captures carbon at a rate far higher than tropical rainforests. By destroying the seagrass of the Persian Gulf, we aren't just losing a fish habitat, we are releasing massive amounts of stored carbon back into the system, accelerating climate change. Moreover, the Gulf is home to the world's second-largest population of dugongs, shy, gentle sea cows that eat only seagrass. If their pastures are poisoned, these rare animals have nowhere else to go. They are prisoners of a closing sea. The engineering of an oil refinery is a marvel of chemistry, but that also makes it a chemical nightmare when it breaks. Refineries use massive amounts of catalysts and processing chemicals, including heavy metals like vanadium and nickel. In a conflict, these chemicals don't just disappear, they enter the local water table. They find their way into the tissues of the fish that the local population relies on for food. Because these metals biomagnify, they become more concentrated as they move up the food chain. A small shrimp eats the tainted mud, a larger fish eats 1,000 shrimp, and eventually, a human eats that fish. The result is a long-term public health crisis that persists long after the peace treaties are signed. The insane result here is that the damage would be largely irreversible in our lifetime. Because the Persian Gulf is so shallow, averaging only about 100 feet deep, the sun's heat and the high salt levels create a very specific chemical environment. Some pollutants that might break down in the deep, cold Atlantic Ocean stay active much longer in the hot, stagnant waters of the Gulf. We would be turning one of the world's busiest waterways into a dead zone where oxygen levels plummet and only the most toxic species of algae can survive. These algal blooms, fueled by the nitrogen and chemicals released from industrial damage, can create vast patches of water that are literally toxic to the touch. There is also the historical perspective. We have seen what happens when oil enters this specific environment. In 1001, the release of over 5 million barrels of oil into the Gulf created a disaster that took decades to even partially recover from. But today, the infrastructure is much denser. There are more platforms, more subsea pipelines, and much larger refineries. A modern conflict would be hitting an ecosystem that is already stressed by record-breaking heat waves and heavy industrial runoff. It's like hitting a patient who is already in the ICU. The resilience of the Gulf has been pushed to its absolute limit. Another major trauma could move it past the tipping point, where the ecosystem fundamentally changes into something unrecognizable and much less life-supporting. What makes this even more tragic is that the region is a treasure trove of scientific discovery. Researchers are currently finding new species of bacteria in the Iranian salt flats and coastal marshes that have the potential to break down plastics or produce new types of medicine. There is a biological library there that we haven't even finished cataloging. When you bomb an oil terminal near a sensitive wetland, you are essentially burning down a museum of evolution. The loss of biodiversity isn't just a sad story for nature lovers. It's a loss of potential solutions for future human problems. The physical impact of high-pressure underwater events, like the rupturing of a massive subsea pipeline, is also a concern. The shock waves are devastating to marine mammals like dolphins and porpoises. Their acoustic-based navigation is shattered, leading to mass strandings. In a shallow, it bounces off the floor and the coast, creating a chaotic environment where marine life simply cannot function. And then there is the infrastructure of recovery. If the environment is poisoned, how do you clean it up in a conflict zone? Traditionally, oil spill response requires a massive coordinated effort between nations. It requires specialized ships, thousands of miles of booms, and high-tech skimmers. In a state of war, this coordination vanishes. The oil is allowed to drift and sink for weeks or months without any intervention. By the time the cleanup begins, the damage has already moved from the surface to the very DNA of the ecosystem. It becomes a problem of decades, not days. The global atmosphere would also feel the impact. The fires from targeted oil assets release massive amounts of carbon black. These tiny particles can travel thousands of miles and settle on glaciers and ice caps. When dark soot lands on white ice, it absorbs more sunlight, causing the ice to melt faster. A conflict in the Middle East can directly accelerate the melting of the Arctic. The world is a closed loop, and the smoke of war is a global traveler. Think about the fishermen. Millions of people along the coast of Iran and the neighboring countries rely on the sea for their daily bread. If the shrimp and fish stocks are decimated by a chemical catastrophe, the resulting poverty creates a new cycle of instability. People who can no longer feed their families are forced to migrate, creating a massive refugee crisis that strains the resources of neighboring regions. This is what we call environmental security. You cannot have a stable political world on top of a crumbling biological one. The insanity of the situation is that the technology used to extract and refine this oil is incredibly high-tech, but the safety net for the environment is remarkably thin. We have built a world that is dependent on these systems, yet we treat them as tactical targets without acknowledging that they are also environmental time bombs. If you target the oil, you aren't just hitting a regime's wallet, you are hitting the water, the air, and the future of everyone who lives in that hemisphere. But why should someone interested in scientific discovery care? Because the Persian Gulf is a time machine. Due to its extreme conditions, a life there gives us a preview of what all oceans will look like if global temperatures continue to rise. It is the world's most important laboratory for studying climate adaptation. If we destroy this laboratory, we lose our clearest window into the future of our planet. We lose the chance to see how life can find a way to thrive in 95-degree water. There is also the mystery of the deep Gulf. While it is mostly shallow, there are deep trenches and underwater canyons along the Iranian coast that remain largely unexplored. These areas could house species we don't even know exist. Specialized organisms that live in the dark, pressurized zones of the Gulf. A massive influx of heavy, sinking oil toxins would reach these depths through a process called marine snow, where organic particles carry the poison down. We could be erasing species before we've even discovered them. The scale of the reclamation needed after such an event is almost beyond human capability. How do you scrub 1,000 miles of mangrove roots? How do you remove millions of tons of oily sediment from a seagrass meadow without destroying the grass itself? In many cases, the scientific answer is that you can't. You simply have to wait and hope that nature survives the assault. But in a shallow, hot sea like the Gulf, that wait could be measured in centuries. The result of bombing this infrastructure would be a chemical shifting of the region. The very molecules of the environment would change. The balance of nitrogen, the pH of the water, and the composition of the soil would all be altered. We would be creating a new, more hostile version of the Earth in that region. This is why the environmental stakes of conflict in the Middle East are so high. It's not just about who wins the day. It's about whether the land and sea can ever support life again. Consider the mangroves again. They aren't just trees. They are carbon-capturing machines. They are more efficient at storing carbon than almost any other forest on Earth. When they die, that carbon isn't just lost. It is released. It's like a carbon bomb going off alongside the chemical one. The environmental tragedy is multi-layered. One layer of damage triggers the next, leading to a cascade of failure that is impossible to stop once it begins. What we also have to consider is the brine factor. Many of Iran's industrial sites are co-located with power and water facilities. If these systems are damaged and continue to leak concentrated brine or cooling water into the shallow coastal zones without the proper mixing, they create underwater deserts. These are patches of water with so much salt and so little oxygen that nothing, not even the tough Gulf fish, can survive. These deserts can spread, effectively sterilizing the coastal waters for miles. The resilience of nature is incredible, but it has its limits. The Persian Gulf has been inhabited by humans for over 10,000 years. We have fished it, sailed it, and lived beside it through countless empires. But in the last 50 years, we have industrialized it to a point where it has become incredibly brittle. A single major conflict targeting the industrial heart of the region would be the final straw for an ecosystem that has given so much to human civilization. Scientific studies of past spills in the region show that the weathering of oil in the Gulf is unique. The intense sun bakes the oil into a pavement-like substance called asphalt crust that can coat the intertidal zone. This crust prevents the exchange of gases between the air and the soil, meaning that even years later, no new plants can grow there. It turns a living beach into a parking lot of toxic waste. This is the visual reality of what poisoning entire ecosystems looks like. It's not just dirty water. It's the literal mummification of the landscape. The bird migrations are perhaps the most tragic element. These creatures know no politics. They simply follow the magnetic lines of the earth and the promise of food. They arrive in the Gulf expecting a sanctuary and find a trap. When a parent bird is coated in oil, it returns to the nest and transfers that oil to the eggs. Even a tiny drop of oil is enough to prevent the egg from hatching. This means a single oil release can wipe out an entire generation of birds across the globe. And what about the dolphins? The Persian Gulf is home to the Indo-Pacific humpback dolphin and the finless porpoise. These are already endangered and highly sensitive animals. They live in small, localized groups. If their specific bay or estuary is hit with an oil slick, that entire subpopulation is effectively erased. There is no replenishment from the open ocean because the Gulf is so isolated. Once they are gone from the Gulf, that unique genetic branch is lost to the world. The call to protect this infrastructure isn't just about preserving assets. It is about recognizing that in the 21st century, our life support systems are industrial. When we build massive refineries on the edge of sensitive mangroves, we are creating a symbiotic relationship between our economy and our ecology. If the economy breaks, the ecology breaks with it. This is a scientific fact that must be integrated into our understanding of global security. One of the most profound recent discoveries in the Gulf is the presence of deep-water corals that don't need light to survive. They live in the deep channels of the Strait of Hormuz. These cold-water corals are ancient and slow-growing. They are like the redwoods of the sea. Because they grow so slowly, often only a few millimeters a year, any damage to them is permanent on a human timescale. A sunken ship or a cloud of toxic sediment would be their end. We are talking about structures that have been growing since before the Roman Empire being destroyed in a second. The result is insane because we have the power to prevent it, yet we are constantly on the verge of it. As a society interested in scientific discovery and the wonders of nature, we have to see the Persian Gulf as more than a transit zone. It is a biological miracle. It is proof that life can adapt to the most extreme conditions. It is a blueprint for how we might survive a warming world. To poison it would be more than an environmental disaster. It would be a betrayal of our own future. The mangroves, the dugongs, the supercorals, and the ancient seagrasses are all part of a single, breathing system. They work together to keep the Gulf alive. If one part is hit, the whole system begins to stumble. The oxygen drops, the heat rises, and the toxins spread. It is a slow-motion collapse that we have the technology to map, but perhaps not the wisdom to stop. In conclusion, the prospect of conflict involving Iran's oil infrastructure is a threat to the global commons. The chemical and biological risks are so high that they should be considered a red line for humanity. We are playing with a toxic fire in a room filled with the world's most precious biological treasures. The result of a conflict wouldn't just be insane. It would be an environmental ending. We have to look past the headlines and see the water. We have to see the life that is fighting every day to survive in the hottest sea on Earth. Protecting the Gulf isn't just about saving nature. It's about saving the only time machine we have that shows us how to live on a hotter planet. Let's hope we choose to keep the laboratory open and the ecosystems breathing. The world is watching the Persian Gulf, but it's time we started looking beneath the surface. The poison is ready, the infrastructure is targeted, but the life there is still fighting. Let's make sure it doesn't have to fight us, too. The legacy of our era shouldn't be the asphalt crust on a Persian beach. It should be the discovery of how we saved the most resilient ocean on Earth. The choice is ours, and the clock, like the tides of the Gulf, is relentlessly moving.